fellow scientist and mathematician. Welcome to my YouTube channel, which focuses on mathematics and science. Welcome, and let us learn together, whereby mathematics is simplified together with the physics from the fundamentals, so that every person can learn and understand the rules step by step. My channel name is Luke Aaron 1. Welcome, and let us learn together. Welcome to our circular uniform motion part 2, whereby we want to look at the numerical example of uniform circular motion. So here we are given a bicycle which has a wheel of radius 35 centimeter, and it makes 1 revolution per second. So the first question, we have to determine the angular velocity of the wheel. So we have to determine the angular velocity of the wheel. So angular velocity, the symbol is omega. Angular velocity will be given by the number the number of revolutions. In the other ones, it is the rate of change of. It is given by the rate of change of angular velocity is given by the rate of change of angular displacement with the time. Now our angular displacement, it is the number of cycles made, and here we have 1 revolution. So the distance in 1 revolution, it is 2 pi divided by t, which is equal to 2 pi over time. Time is 1 second. Per second means time is 1 second, which will give us 2 pi radian. It will give us 2 pi radian per second. So this one is in radian. 2 pi, it is the angular displacement. So it will give us 2 pi radian per second. Example 2, we want to get the increase in angular displacement of the wheel at a point on the rim in 10 seconds. So we are going to use this formula. Angular displacement, that is omega, is given by theta in radian over time taken. This implies that the angular displacement from here will be given by, we multiply by t both sides. There. So our time is we have 10 seconds. Our omega is 2 pi radian, which will give us the unit of omega. It is 2 pi radian per second. So we substitute it here. Time is in second, so second and the second will cancel, and we will be left with the 2 pi radian. So that is the increase. That will be the increase in the displacement of the particle, of the increase in the angular displacement of the wheel at a point on the rim when it is 10 seconds, as given there. So the next question is the distance traveled by the bicycle in 10 seconds. So distance is given by s, that is the arc length, is equal to, because the wheel is moving around, will be given by radius multiplied by angular displacement. Our radius, we are given our radius here, it is 35 centimeter. So we convert 35 centimeter into meters, it will be 0.35 times our angular displacement in 10 seconds. We have found it here as 20 pi radian, which will give us 0.35 times 20 will give us 7. It will give us 7 pi, and this will be in meters. It will give us 7 pi meters. So that is the distance traveled by the bicycle in 10 seconds. So it is radius multiplied by the angular displacement in 10 seconds, which is 20 pi. There. The next question, it is the linear velocity of the wheel. Linear velocity of the wheel. So linear velocity V is given by radius. Which radius should be in meters, multiplied by angular velocity. Our radius is 0.35 times our velocity, our angular velocity, we found it here. Our angular velocity, we found it here. It is, our angular velocity is 2 pi radian. So we substitute here with the 2 pi, which is equal to 0.35 multiplied by 2 will give you 0.7 pi meters per second. So that is the linear velocity of the wheel. Next question is the centripetal acceleration of the wheel. So centripetal acceleration of the wheel will be given by A, will be given by V squared divided by R. Our V is our V here, we have found it there. It is 0.7 pi. We square this, square everything square, divided by our radius is 0.35. Yeah, our centripetal acceleration can be given also by this formula, omega squared R. We can substitute the value of omega. Our omega is this one. We found our angular velocity is 2 pi radian. So we can substitute here with 2. We can substitute here with 2 pi. And we square this. Then we multiply by our radius, which is 0.35. When we simplify this, we are going to find is equal to 1.4 pi squared. 1.4 pi squared. So which is the same as this. So there are two formulas of getting centripetal acceleration. You can get it in terms of linear velocity squared divided by radius. Radius should be in meters. Or you can get it in terms of omega squared divided by R. I mean omega squared, that is the angular velocity times radius. You substitute there. Next question is the periodic time of the wheel. So periodic time of the wheel, it is given by t, which is given by the circumference. The circumference has to do with the number of revolutions made. So because the wheel is turning around, the distance will be given by 2 pi r over spin dv, which is equal to 2 pi divided by r omega. We are using the fact that v is given by r times omega multiplied by r. So r will cancel and we will be left with 2 pi divided by omega, which is equal to 2 pi divided by our omega. We found it in part A of this question. We found it here in part A in this question. And we found the answer to be, the answer was 2 pi. The answer was 2 pi. So we are going to substitute. We are going to substitute here with the 2 pi. And we are going to find that it is 1 second. So period means the time taken for the particle to complete one revolution. And actually this answer can be found directly from the question here, whereby we are told that a bicycle wheel with radius 35 centimeters makes one revolution per second. So the time period, as it is the time taken for the particle to cover one complete cycle. But you can do it using the formula as we have found here, whereby the formula, it is the circumference of the circle, which is 2 pi r divided by velocity v. Velocity v is given by radius times angular velocity. We substitute. The final question for today in this sample question is the frequency at which the wheel is revolving when time is 1 second. The frequency at which the wheel is revolving when time is 1 second. So to get frequency, we are going to use the relationship that 1 over f is equal to t, meaning that f is equal to 1 divided by t. So frequency is given by the reciprocal of period. We substitute 1 divided by our period from this question is 1 second. 1 second, which is equal to 1 hertz. Hertz is the SI unit of frequency. So guys, that's all for today. Thanks so much for your time. Today we have looked at how we can solve a numerical problem of uniform circular motion. And we have found that to get the angular velocity, it is given by angular displacement divided by time. Then to get the angular displacement, it will be given by angular velocity times time. That is the angular displacement. Then distance traveled by the bicycle in 10 seconds will be given by radius times angular displacement. That is the arc length. And so we substitute and we are going to get this answer here. We are giving you our answers in terms of pi. You can simplify from your calculator. Pi is 22 over 7, or you leave your answer that way. It is acceptable. It is acceptable to leave your answer that way. Now, next, we have looked at the linear velocity of the wheel, which is given by radius times omega. We have substituted there. The centripetal acceleration of the wheel, which is given by v squared over r. That way. V squared over r is the centripetal acceleration. And It can also be given in terms of omega squared r, and the answer is the same because it's the same formula. The other question was the periodic time of the wheel. The periodic time is given by the distance over speed. Period or time is given by distance over speed. Our distance is 2 pi r divided by speed. Speed, linear speed is v omega, and the r has cancelled out. 2 pi omega, which is equal to 2 pi over 2 pi, which is, by substituting omega, our omega is 2 pi from the first question. We found it to be 2 pi here. So that is the principle we are applying there. Then, it is equal to 1 second. The frequency at which the wheel is revolving when the time is 1 second. So the relationship between frequency and the period is that frequency is equal to 1 over period. So that is why we have divided here with 1. Period is 1 second. And we have found that 1 divided by 1 is equal to 1 hertz. Thanks so much for your time. Next time we are going to look at we are going to consider vertical, circular motion. So our focus next time will be vertical circular motion. That will be our focus next time, vertical circular motion. Thanks guys for your time. See you next time as we continue learning. So much for watching this study. Kindly like, subscribe so that you won't miss any single video which I upload now and then. Also, you can make a comment there. You can suggest any area of study which you would want me to address, and I will be more than willing to tackle it on your behalf. Thanks so much for your support, guys.